everyone, welcome to my YouTube channel. Today I'll be taking you guys on number-based system. Number-based is a branch of mathematics that deals with the representation of digits into a specific base. For example, if we have 11011 base 2, the number 11011 is known as the digit, while the number 2 is known as the base. Now if you take a good look at this, you will notice that the digit 11011 is tagged to a specific base, which is 2. That makes this a number base. Another example is 948 base 10. Now if you take a good look at this, you will notice that the number 948 is tagged to a specific base, which is 10. That makes this a number base. Now let's move to the rules guiding number base. Rules guiding number base. There are two basic rules guiding number base. Rule number 1, ensure that the base is always greater than any of the digits. I repeat, ensure that the base is always greater than any of the digits. For example, if I have 11011 base 2, if you take a good look at this, you will notice that the base, which is 2, is greater than any of the digits involved here. What do I mean? I mean that 2 is greater than 1, 2 is greater than 1, 2 is greater than 0, 2 is greater than 1, and lastly, 2 is also greater than 1. That makes this a number base because the base is greater than any of the digits here. Second rule, ensure that the base is not equal to any of the digits. I repeat, ensure that the base is not equal to any of the digits. For example, if I have 1504 base 5, if you take a good look at this, you will notice that the base, which is 5, is equal to one of the digits involved there, which is 5. That is to say that this is not a number base because the base 5 is equal to one of the digits, which is 5. Now let's move to types of base. We have two types of base. Number 1, we have the standard base, and number 2, we have the other base. Number 1, we have the standard base, and number 2, we have the other base. Standard base are base that are base 10. When we see a number in base 10, we say that that number is in standard base. Standard base are otherwise known as base 10 or denary or decimal. So when we see a number in base 10, we can equally say that that number is in standard base, or that number is in denary, or the number is in decimal. That is for standard base. Now the second one we say is other base. Other base are base that are not base 10. For example, base 2, base 3, base 4, base 5, base 12, base 16. Any number that is not in base 10 are number in other base. Let's take a look at the stages in number base. There are 5 different stages in number base. Number 1, conversion of other base to base 10. Number 2, conversion of base 10 to other base. Number 3, conversion of one base to another base. Number 4, arithmetic of number base. And number 5, equation involving number base. For the sake of this lesson, I will be taking you guys on only the first stage, which is conversion of other base to base 10. And in my subsequent videos, I will be taking you guys on others. Let's take a look at the conversion of other base to base 10. This is the process of changing a number from other base to a number in base 10. For example, if we are asked to convert a number from base 2 to base 10, or from base 12 to base 10, or from base 8 to base 10. In this process, we use a successive multiplication method. For example, convert 110101 base 2 to base 10. Solution. We bring out the question here. 110101 base 2. The first thing we need to do is to do a visual check to know if this is a number base or not, using the rule. Now the base here, which is 2, is greater than any of the digits involved in this question. That automatically makes this a number base. Secondly, I will start by putting a power on each of the digits, starting from 0, from my right hand side down to my left hand side. I'll start here. I'll say 0, 1, 2, 3, 4, 5. From my right hand side down to my left hand side, starting from 0. The next thing I will do is to start using the successive multiplication method. 1 times 2 raised to the power 5. That is the digits times the base raised to the power here on top of the digits, plus 1 times 2 raised to the power 4, plus the next one, 0 times 2 raised to the power 3, the next one, 1 times 2 raised to the power 2, plus 0 times 2 raised to the power 1, and lastly 1 times 2 raised to the power 0. Then I'll continue. Equal to 1 times 2 raised to the power 5. It means 2 in 5 places by multiplication. 2 times 2 times 2 times 2 times 2, which gives me 32. Plus 1 times 2 raised to the power 4 means 2 in 4 places by multiplication, which gives me 16. Plus 0 times 2 raised to the power 3, 2 in 3 places by multiplication, which is 8. Plus 1 times 2 raised to the power 2, which is 4. Plus 0 times 2 raised to the power 1 is 2. Plus 1 times 2 raised to the power 0 is 1. In math, any number raised to power 0 is 1. The next step, 1 times 32 is 32. Plus 1 times 16 is 16. Plus 0 times 8 is 0. Plus 1 times 4 is 4. Plus 0 times 2 is 0. And lastly, plus 1 times 1 is 1. The next step will now add up everything. 32 plus 16 is 48. 48 plus 0, 48. 48 plus 4, 52. 52 plus 0, 52. And lastly, 52 plus 1, 53. So we have 53 base 10. Now we have successfully converted 110101 from base 2 to a number in base 10, which is 53 base 10. Let's take a look at example 2. Convert 134 base 5 to a number in denary. When we see the word denary, it means base 10. Because when I talked about the types of base, I mentioned that we have standard base and other base. Another name for standard base is base 10 or denary or decimal. So the question can ask us to convert it to denary. They equally mean we should convert to base 10. Let's move to the solution. The question 134 base 5. From what I have here, this is a number base because the base, which is 5, is greater than any of the digits. The next step, I will start putting a power on each of the digits, starting from 0 from my right hand down to my left hand side. And I have 0, 1, 2. Then I move. The next thing, 1 times 5 raised to power 2. From here, 1, which is the digit, times 5, which is the base, raised to the power, whatever I have on top of that digit, plus 3 times 5 raised to power 1, plus 4 times 5 raised to power 0. Then I continue. Equal to 1 times 5 raised to power 2 is 5 times 5, which is 25. Plus 3 times 5 raised to power 1 is 5. Plus 4 times 5 raised to power 0 is 1. Then we proceed. 1 times 25 is 25. Plus 3 times 5 is 15. Plus 4 times 1 is 4. Equal to 25 plus 15 is 40. 40 plus 4 is 44. 44. Then I put my base, which is 10. Now I have successfully converted the number 134 in base 5 to a number in denary, which is 44 base 10. Let's take a look at example 3. Example 3. Express 111.11 base 2 in standard base. Now when we are asked to convert a number in standard base, they are equally asking us to take that number to a number in base 10. Let's take the solution. One 111.11 base 2. If you take a good look at this, you will notice that this is a number base because the base, which is 2, is greater than any of the digits involved here. And this question is quite different from what we've done earlier because this one has a decimal here. Now what I need to do is to separate these two, the numbers before the decimal and the numbers after the decimal. The numbers before the decimal, I will start by putting a power of 0 from my right hand side down to my left hand side. Just like this, I will have 0, 1, 2. Not from this place. I will start by putting my 0 from the last number before the decimal. Down here. 0, 1, 2. I will continue that same way. Then the number that begin after the decimal, I will start by putting a power of -1, -2, and down to my right hand side. Now let's continue. We have 1 times 2 raised to power 2. That is the number here, the digits times the base raised to the power on top of the digits. Plus 1 times 2 raised to power 1. Plus 1 times 2 raised to power 0. Plus 1 times 2 raised to the power of -1. Plus 1 times 2 raised to the power of minus 2. Then we continue. Equal to, here I will have 1 times 2 raised to the power 2 means 4, which is 2 times 2, 4. Plus 1 times 2 raised to the power 1, 2. Plus 1 times 2 raised to the power 0 is 1. Plus 1 times 2 raised to the power minus 1. When we have a number raised to the power of minus sign, it equally means 1 over whatever we have there. Then this will give me 1 over 2 raised to the power 1 is 2. This 1 over, it's because of the negative power we have here. So 1 over is because of the negative power. Then I have 2 raised to the power 1, which gives me 2. Plus 1 times 2 raised to the power minus 2 will give me 1 over 4. The negative power here is the reason why I have 1 all over. Then I have 2 raised to the power 2, which will give me 4. Then I continue. 1 times 4 is 4. Plus 1 times 2 is 2. Plus 1 times 1 is 1. Plus 1 times 1 over 2 is 1 over 2. Plus 1 times 1 over 4 is 1 over 4. Then we have equal to, the next thing that we need to do is to add up all the whole numbers together. Now we have 4 plus 2 is 6 plus 1, which is 7. 7 plus, and I will have the fraction 1 over 2 plus 1 over 4. And I have equal to, then I will add up this fraction together by taking the LCM, which is the lowest common multiple. And I have 7 plus, the LCM of these two is 4. 4. Then from here, taking the LCM, I have 4 divide 2, which is 2. 2 times 1, which is 2. Plus 4 divide 4, which is 1. 1 times 1, which is 1. Then I have equal to 7 plus 2 plus 1 is 3. And I have 3 over 4. And I have equal to 7 plus 3 over 4 is 0.75. 0.75. Then 7 plus 0.75 will give me 7.75 is 10. Now we've successfully converted 111.11 from base 2 to a number in base 10, which is 7.75 base 10. Let's take a look at the last example. Example 4. Change 241.23 base 8 to base 10. Solution. .23 base 8. From this, I will start by putting the power on each of the digits. For this part, I will have 0, 1, 2. That is for the number before the decimal. And for the number after the decimal, I will have minus 1, minus 2. Then I proceed. 2 times 8 raised to power 2. 2, which is the digit here, times 8, which is the base, raised to the power of the index on the digits, plus 4 times 8 raised to the power of 1. 4 times 8 raised to the power of 1. Plus 1 times 8 raised to the power of 0. plus 2 times 8 raised to the power of minus 1 plus 2 times 8 raised to the power of minus 1 plus 3 times 8 raised to the power of minus 2. Minus 2. Then we proceed. Equal to 2 times 8 raised to power 2 is 8 times 8, which is 64. Plus 4 times 8 raised to power 1 is 8. Plus 1 times 8 raised to power 0 is 1. Plus 2 times 8 raised to power minus 1 is 1 over 8. Plus 3 times 8 raised to power minus 2 is 1 over 64. Because 8 raised to power 2 is 64. But because of the negative power, then I have 1 over 64. And we proceed. 2 times 64 is 128. Plus 4 times 8 is 32. Plus 1 times 1 is 1. Plus 2 times 1 over 8 is 1 over 4. Because when we have 2 here, 1, 2 here, 4. That's how I got 1 over 4. Plus 3 times 1 over 64 is 3 over 64. Because 3 cannot go in 64. So I have 3 over 64. Then I continue. 128 plus 32 plus 1. What I want to do now is to add up all the whole numbers together. 128 plus 32 is 160. 160 plus 1 is 161. Plus 1 over 4 plus 3 over 64. And I continue. And I will have 161 plus, I will take the LCM of the two fractions here, 1 over 4 plus 3 over 64. The LCM for both of them is 64. So 64 divided by 4, which is 16. 16 times 1, which is 16. Plus 64 divided by 64, which is 1. 1 times 3, which is 3. So here I have equal to 161 plus 16 plus 3 is 19. So I have 19 over 64. Then I continue. Equal to 161 plus. Now the next thing is to take 19 over 64. That is 19 divided by 64 is 0.2969. 0.2969. That is 19 over 64. Then I continue. Equal to 161.2969 base 10. So this is our answer. You can also approximate this to a 3 decimal place by saying approximating to 161.297 base 10. So I've successfully converted the number 241.23 from base 8 to a number in base 10, which is 161.2969 base 10. in 4 decimal places, or 161.297 in 3 decimal places. Alright guys, we've come to the end of today's lesson. Thank you guys for watching my video till the end. I really appreciate you guys. Kindly subscribe to my YouTube channel, like my videos, share my video to family and friends. See you guys next week. Bye.